So question 1 reads, which of the following statements accurately describes the effect of increasing the temperature on the rate of a chemical reaction? Well, we know that an increase in temp is going to result in more collisions, and more of those collisions will hit hard enough to overcome the activation energy. So we would expect this to increase the rate of our reaction. So increasing the temperature always decreases the rate of the reaction? No. Increasing the temperature generally has no effect? No. Increasing the temperature usually increases the rate of the reaction. So we have C there. And again, the reason for that is as this temperature goes up, you can expect those particles to collide more often and collide harder, so a larger portion of those collisions will be successful in overcoming that activation energy. Question 2, what role does a catalyst play? Well, a catalyst we know speeds up the reaction, but it does that by lowering the activation energy. So if there's a certain threshold of energy that a reaction has to overcome in order to react, a catalyst can bring that activation energy down to a lower level, so it's easier for the reaction to overcome that activation energy. So the answer here is going to be D. A catalyst lowers the activation energy by, and therefore increasing the rate of the reaction. Question 3, how does an increase in the concentration of reactant particles in a solution affect the rate of a reaction? So compare here, we have a solution, and here we have a much more concentrated solution. Going back to collision theory, more particles means there's more collisions, which means there's more opportunity for this reaction to occur. So that's going to lead us to believe that an increase in the concentration should result in an increased rate of this reaction, which is what C says. Question 4, in a reaction involving gaseous reactants, what effect does an increase in pressure have? This is exactly the same idea as the previous problem, but instead of this being a solution, pretend it's a gas. So this gas on the left here has 5 particles, but this one might have a whole lot more, so this is going to have a much higher pressure. So in terms of a gas, pressure is the concentration of a gas. They're effectively the same thing. So an increase in pressure means there's a higher concentration of those particles, which means they're more likely to collide, so we would expect this to have an increase in the rate of the reaction. Question 5, how does an increase in the surface area or a decrease in the particle size affect the rate? These both mean the same thing. If I were to drop a cube of, say, some sort of metal into some acid here, the acid is going to corrode that metal away. But if I were to grind this metal up, so it's no longer in a cube, let's get that out of here. If I were to grind that into, say, some sort of powder, and I sprinkled that powder in, that's going to have a much smaller particle size, because earlier it was the big cube, now it's these tiny little grains. This much smaller particle size results in a huge increase to the surface area. And because of that, there's more opportunity for these molecules to collide, so the reaction rate will increase. And then question 6, if the concentration of reactant particles in a solution is halved, how does this change impact the rate of the reaction? So again, this is similar to the previous one. Here we have a solution with, let's just say, 10 particles. Here we have one with 5. Having the solution is the same, having the concentration is eliminating the opportunity for some of those particles to collide. So I would expect that the reaction rate is going to decrease, and based off our answer choices here, the only one that's good is A.